So I think one takeaway is don't let me write my own intro. Or maybe do if you like it. I'm here to talk to you about pop culture, the pendulum, and progress. First, I'm going to use my superpowers as a speaker to make you aware of your posture. Suddenly, just sit up straight, stretch a little bit. I think you'll feel better. I know that when I sit down, I turn into like a pretzel, and then I regret it. So you'll feel a little better. You're going to hear a lot about technical things today. There's going to be a lot of great technical content, and this is going to be slightly less technical, but I think it will help us absorb some of those technical ideas and kind of help frame those. The question I want to talk about today is, how does software progress? When I say software, I don't mean an individual piece of software. I mean the software industry as a whole. And I'd like to give a framework to help us understand and deal with change in software. I hear about two main metaphors to describe progression in software. One is software as an art. The other is software as a science. And I'd like to examine these a little bit. We will start with a science, just like this penguin. Here's kind of like a dummy's idea of science. This is my idea of how science worked for a long time. There's this timeline from the beginning of the world until now. And for most of the history of the universe, all these dumb people had stupid and wrong ideas. And then somehow, like conveniently close to my lifetime, someone came up with the right idea. And they got it right finally. And I remember thinking, man, it's so weird how people got it wrong all this time, but I'm glad they have it right now. That's not quite how science works. My favorite model comes from this book by a guy named Thomas Kuhn. It's called The Structure of Scientific Revolutions. And it's pretty readable. It's not very technical or super academic. If you're interested in these topics, I'd recommend it. And he basically gives a model for what science is and how it progresses. To talk about that, we're going to have to descend into the world of stupid business words like teamwork and synergy and, yes, even paradigm. Together, these form the triangle of stupid business words. But actually, paradigm is a real word before it was a stupid business word. And Kuhn was the guy that kind of popularized it. He didn't create it, but he kind of brought it to popular attention. And it has a very specific meaning to him. To us, it means like a thing. But to him, it means an idea that people gravitate towards. But it's not just the idea. It's all the questions that arise from that idea. So I'll give you an example. You could say object-oriented programming is a paradigm. There's a set of concepts around building software that make up object-oriented programming. And if you believe that object-oriented programming is the right way to build software, it also suggests all these additional problems, like how to use inheritance to model real-world hierarchies, or is composition a better way to do things? These are questions that only make sense if you assume object-oriented programming is the way to go. So something like, can we model side effects in a type system? That's not a question that would occur in the object-oriented paradigm because it doesn't worry about those kind of things. So a paradigm is an idea, but all of the questions that arise also around that idea once you accept that idea. So Coons Model is science is made up of paradigms, and you do research and you answer all these questions, and as you're doing research, you start to find these things that don't fit in paradigms. And at first, they kind of get swept under the rug, but eventually they pile up enough so that people decide, hey, maybe this paradigm isn't the right fit. Maybe we need some new model that explains all these anomalies, all these things that don't fit. And then it changes into a new paradigm. So there's this cycle. Paradigms are always shifting. I shudder when I say that. It's another dumb business word. But there's this cycle of paradigms, research within those paradigms, finding things that don't fit, new exploration towards new theories, and then a new paradigm. Here's a quote by him: "The successive transition from one paradigm to another via revolution is the usual developmental pattern of mature science." And just because I want to feel like I'm more friends with him, I changed it to Tommy Kuhn instead of Thomas Kuhn. So now we're buds. So that's a model of science, and I think it makes a lot of sense. Is software science? Well, it displays some aspects of science. We definitely have forward progress in some ways. This is a paper from the 70s called "On the Criteria to be Used in Decomposing Systems into Modules." And it was a look at how you use modularity to develop systems, basically. How you split up your parts of your program into different pieces. And it's interesting in that right. It's got some good ideas. But it's also interesting because the small toy example system that they used in it, here is a description of it from the paper. The quick index system accepts a list of lines, and each line is a list of words. Any line may be circularly shifted by repeatedly removing the first word and appending it to the end of the line. The quick index system outputs a listing of all circular shifts of all lines in alphabetical order. So you have a line of words, you take the first word, put it at the end, do that until you've cycled through all the words, do that for every line, sort that. And then, this is a small system, except under extreme circumstances, huge database, no supporting software. Such a system could be produced by a good programmer within a week or two. Well, I guess I'm a super good programmer because I produced it in about 20 minutes. No, I don't think that's the answer. I think the answer is that there's been progress. We work at a higher level of abstraction in most cases. We have larger standard libraries. The important, don't worry about the code. You don't have to understand it. That does what the other slides said it needed to do. But it didn't take very long to do because there's been some progress. We have a lot more tools at our disposal. Here is a graph of basically bandwidth over time. And it's in a log scale, so it's increasing exponentially. It basically doubles every 2 years. So there's a ton of progress in like the physical infrastructure of networking, and we can stream video now, which was kind of unthinkable back in the 80s. So you look around and you definitely do see progress. But I think there are some arguments against that too, and a lot of them come from this guy. Does anyone know who this person is? Alan Kay, wow, I'm glad you knew that. Thank you. Yeah, this is Alan Kay. Alan Kay is one of those kind of old school computer scientist people that did a bunch of famous stuff. He worked at Xerox PARC in the 70s. He invented Smalltalk, which is a famous programming language that doesn't get used that much anymore. He basically created the idea of object-oriented programming and modern GUIs. And he's one of those like alpha rock star people that you might have worked with. Maybe you would call them decoys if they couldn't back it up, but he can actually back it up. Like he says stuff like, everyone's doing it wrong, and if they just did it this way, it would be better. And then he like does it and proves it instead of just tells everyone they're stupid. But pay attention to this winning smile because it's about to spit out some sick burns. Computing is complete pop culture. Pop culture holds a disdain for history. Pop culture is all about identity and feeling like you are participating. It has nothing to do with cooperation, the past, or the future. It's living in the present. I think the same is true of most people who write code for money. They have no idea where their culture came from, and the internet was so well done that most people think of it as a natural resource, like the Pacific Ocean, rather than something that was man-made. When was the last time a technology with a scale like that was so error-free? The web, in comparison, is a joke. The web was done by amateurs. But he said it with a smile. We're not done yet. There's more. In the old days, if you reinvented the wheel, you would get your wrist slapped for not reading. But nowadays, people are reinventing the flat tire. I'd personally be happy if they reinvented the wheel, because at least we'd be moving forward. If you think like Twitter arguments about React Router or whatever the Twitter drama is today are bad, like talk to these people. They know drama. So he has some issues with this idea of progress. And I think he's got a point. There are a lot of old good ideas that never caught on and are being re-implemented worse nowadays. HyperCard was amazing, and it kind of looks like the web, but it has really powerful tools to let everyone create content very easily without being kind of locked down into some platform. Smalltalk, the language he created, I mean, like, of course he's going to think it's amazing and everyone should use it, and everyone who doesn't is wrong. But it has some awesome things in it. It was built with developer tools in mind. It had this graphical environment for kind of inspecting your program and manipulating it at runtime. It was really powerful, and we're just starting to see like good graphical dev tools in the web. So we're kind of getting there in some stuff. Erlang is an old language that solves lots of distributed computing problems, and we're kind of noticing it now. How many of you have written Java or C++? I won't say anything else to abide by the code of conduct, but Java and C++ have a type system. it has some problems. And in the 60s, this guy named Hindley, I think it was Hindley, maybe it was Milner, I don't know, invented a type system. And it got ignored for decades. And now it's kind of gaining more popularity, but it solves a lot of problems that the Java and the C++ type system have. So there are all these old ideas that haven't quite made it in software that kind of make me feel like it's not quite a science because it's not progressing constantly like science is. Well, maybe it is art. Let's look at how art progresses. This is Django Reinhardt. He is one of the best jazz guitarists ever. He has 3 fingers, actually. He lost 2 of them in a fire. And his career happened like after he lost those fingers. So he did all this with 3 fingers. This is a song called Minor Swing that is not playing. If someone could like sing it, that would be good. Yeah, I think I got something plugged in. No, it sure didn't. I just like found stuff up here and plugged it in and I assumed it would work. It turns out that's not a good strategy. Okay, let me try again. There we go. That's Django Reinhardt. This is in 1937, decades ago, a long time ago. This was like cutting edge jazz music back then. And he wrote a lot of jazz standards too. How many people know who this is? Jimi Hendrix, right? He's probably the most famous guitarist that's ever lived. This is All Along the Watchtower. It's a little loud. This is maybe like 3 decades after Django in that last song. Does anyone know who this is? Steve. Yes, someone said Steve Vai, and I don't know how to pronounce it. Steve Vai, Steve Vai. Yeah, he's a giant weirdo. He's also an incredible guitarist. He's kind of contemporary around nowadays, and he sure plays a lot of notes real fast, right? He's really good. So my question is, who is better among these 3? And I would argue that there are technical differences in their skills, but it's not really better. You can't really compare them because it's art. It's all about aesthetics and how it makes you feel. You might hate one of the genres of music that one of these 3 people plays. Or you might just really like one of the songs, right? Art is inherently subjective, and it's based on the reactions that it generates in the people that consume it. So in art, there isn't better or worse, there's just different. And different happens all the time. Art has this idea of change, kind of for change's sake, built in. Like culture changes, art changes along with it. And art from 20 years ago is not the same as today. So these 2 ideas of aesthetic value and then change for the sake of change, to me, are part of art. And looking at art that way, I would ask, is software art? This is, well, how many of you have heard of Why the Lucky Stiff? Okay, a few of you. More of you are about to just have your life improved right now. He was a Ruby developer in the 2000s, and he was bonkers in like the best way. He wrote this guide called Why's Poignant Guide to Ruby, which was supposedly a book to teach people how to program, but mostly it was like cartoons and weird sidebars and nonsensical stories and just totally didn't take himself seriously at all, kind of poked fun at a lot of the technical writing. And to me, he was definitely an artist working through code. Here's a quote from the intro. "I'll be straight with you. I want you to cry, to weep, to whimper sweetly. This book is a poignant guide to Ruby. That means code so beautiful that tears are shed. That means gallant tales and somber truths that have you waking up in the morning in the arms of this book, hugging it tightly to you all the day long. If necessary, fashion a makeshift hip holster for Why's Poignant Guide to Ruby, so you can always have this book's tender companionship." He said that he included an onion with every copy so it would make you cry. He didn't actually. Here is a piece from a band called Repo Electric. They live code with Clojure and Emacs, and they generate the music and the visuals at the same time, just like up on stage. So this is I like this kind of music. I would listen to this even if it wasn't being created in front of me, but the fact that someone is coding this as you sit there is incredible. This is a project called React Game Kit by a guy named Ken Wheeler. It's basically a way to build games in React, doing things that you might not normally do in React. He wrote a whole slideshow to explain it, and he wrote the slideshow in React Game Kit, so you can like play a game to show slides. So I would argue that these are all kind of aesthetic pieces. They all have some kind of artistic value because they express something from their creator and they're trying to evoke a reaction from the people that consume them. One more, we talked about change for the sake of change. Here's a brief timeline of JavaScript tools over the last few years. So I think JavaScript definitely satisfies that part. So we've decided it. Software is art, right? It satisfies those two criteria. Well, I'm just going to leave this scrolling in the background as an example of production code. If you've ever seen production code, you know that it's definitely not art. Software has this idea of commerce tied into it, right? You're writing code for a business in a way that art is not tied to as closely. You have deadlines and features and bug reports and people learning and improving and sometimes not learning or improving and just doing stuff like this. And I think that shows that art can be software, but software isn't just art. Like, they're not totally overlapping. Okay, I want to talk about one more concept, which is that programming is a flat circle. Has anybody seen True Detective season 1? It's such a shame they never made a season 2. This is Rust Cole. He put it eloquently like this: programming is a flat circle. What he means is that there are these cycles that show up in software, that things repeat themselves all the time. I want to give you an example from React. There's this great blog post called "The More Things Change" by, I can't remember their name, so I'm not going to try and say it, by a person. And they talk about the React model of you build your components as kind of functions that take in data and then they return UI. And you can just render all the time and it's not slow because they only re-render what they need to. And then there's kind of some state management where some user will interact with your view and then it'll cause an action to get emitted and it'll go somewhere and get processed and get handed back to your view as data and it'll re-render. And his point was, if you replace some of these boxes, like view with WN Paint, reducer with wind proc, and action with uMessage, this is how you program in Windows 1.0 in like 1990 or whatever. And he programmed, like, I think he might have been working at Microsoft. At least he built apps in Windows. So his point is there are a lot of common threads between the React model of development and the Windows model of development. And he actually says, this was okay, but it brought up all these problems. And then he doesn't say what they were, so he kind of like left me hanging. Like, I want to know what they were and how he solved them. But the point is, you start to see things repeat. There's this kind of idea of pendulums where things swing from one side to the other. And I think this shows up in a lot of different places. I made this, that's why it's ugly. Here's an example of a pendulum. We've got services and monoliths. How many people feel like they're developing in microservices right now? A few people. How many people were doing that like 20 years ago but called it service-oriented architecture? Right? So you have this swing back earlier. It was service-oriented architecture. Then things like Rails came out, and you moved more towards monoliths. And now we have microservices and Docker and serverless, and that's more services. And I think we're going to start to see a little swing back as people realize that it's a nightmare of unending pain. All right, here's another pendulum: thin client, thick client. Does anyone know what this means when I say thin or thick client? Somebody just like shout out a definition. What was that? No physical hard drive. Okay, that's one definition. I would define it as logic happening on the client or the server. So we see that today in server-rendered apps versus browser-rendered apps, right? Browser-rendered apps are thick client because the logic happens on the client, on the user's machine. And server-rendered apps are thin client because the logic happens on the server. But there were more pendulums in the past, too. There used to be able to have like workstations that wouldn't really do anything. Somebody said no hard drive. And you wouldn't have a hard drive. You just have a network connection to some giant like main server thing. And then that swung earlier, too. There used to be giant mainframes that you'd go flip switches on physically. And so there wasn't any client. You were just working on the server. So this is a thing that swings back and forth. A couple more. Frameworks to libraries. I think this swings back and forth as people get frustrated with each approach and assume that if they just go the other way, that all their problems will be solved. So you use a framework. It helps you be productive. You start to get bogged down in all the decisions that the framework makes. You start to disagree with it, feel like it's constraining you. You throw it all away. You find a bunch of libraries. You use them together. You build your own thing. You realize you've built a horrible thing and you're tired of making decisions and you want to go back to the comforting arms of a framework, we've got like Ember on the client side as more of a framework. We've got React and its community as more of a libraries model. And even React is starting to swing a little bit more towards making more decisions for you. I think this is the last Pendulum. Static and dynamic typing. JavaScript is a dynamically typed language. That means the types are just enforced at runtime. There's not a step when you start up your program that makes sure all of your types are correct. And it's starting to swing back a little bit. We've got TypeScript. We've got Flow. These are gradual type systems for JavaScript. You have things like Elm and PureScript that are languages that compile to JavaScript that run in the browser that are statically typed. But even before that, Java and C++ were like the languages everyone used, and those are statically typed. And before that, C was the language that everybody used, and that was basically dynamically typed because you just say pointer void everywhere. So it swings back and forth. I don't have a good transition, so here's a slide with an anteater throwing chairs at a window. Just appreciate that. I've got a giant folder full of stuff like this on my computer, and sometimes when I get sad, I just look at it. It does the trick. So here's what the takeaway is for you all. One takeaway is software is not art, but it shares some characteristics of art. And building art gives you incredible freedom. You're free from constraints and deadlines and code quality, and you get to just do dumb things and mess around. For me, I know when I get burnt out, I go make a stupid side project, and it makes me feel a lot better. You can do things without pressure, and you can express yourself. It's pretty awesome. We can also take some of the ideas from science. So software has this thing, Aaron kind of talked about it with the decoys, where people just say opinions, and they're like, this is fact, because I said it. And that's like not how science works, right? You won't see this in a headline. Scientist just says a thing, and then it's proved. There's this tweet I really like. You can use experience to form conjectures, not to prove propositions. So you can take inspiration from science by finding data to back up your assumptions, or by doing experiments and trying things out, instead of just saying, I tried this once and I liked it or I didn't like it, therefore it's good or bad. And if you do this, you'll be able to kind of arrive at more truth. Another thing is look for the pendulum. Thinking about this idea of a pendulum, of things swinging back and forth, can help you deal with the sometimes overwhelming pace of change in software. I know I get frustrated and stressed and worried about keeping up, but if you look at the change not at this relentless forward progress towards a better future, but instead as a cycle of shifting between values, then you start to relax a little bit. New things might not be new all the time. They might just be different, and you might be seeing things for the second or third or fourth time. This kind of helps you learn. It can also help you predict the future, right? You can say like, oh, we're way at this end of the pendulum. We'll probably go back this other way. And I can either like start learning that or get ahead of it and start building tools for that. And it just kind of helps you deal with the idea of churn. One more point is find old good ideas. Because software isn't a science, it doesn't build linearly on this body of work from the past. There's a history of amazing good ideas that got left behind. I think Alan Kay is right there. And if you study this history, you'll find that a lot of smart people throughout history have figured out a lot of hard problems that we're now seeing again. Starting by reading some of Alan Kay's writings. He wrote this thing called The History of Smalltalk that's kind of like a good read, but it also just has a bunch of ideas about how computing should work that I don't really see around today that are cool and interesting. And this can help you, if you're going to reinvent the wheel, you can at least not reinvent the flat tire, like he said. So because this is a keynote, it's got to be like vague and inspirational, so I'm going to close with these feel-good images to make you feel better about what I've said and just your role in the world. You can do it. Believe in yourself. Just like this hedgehog believes in you. I'm going to let that music, I've got 35 seconds, so I'm going to let it play a little more. Okay, here's some references. I mentioned offhand a lot of resources. These slides will be up somewhere, so if you're interested, you can find them and look in more detail. If you liked the things I'd said, or if you hated them, as long as you don't want to like punch me, let's chat. I'm Jurgensen on Twitter. I do a podcast with Dave that he mentioned, And 5stack.computer, that's my software development shop. The little Lego guy is our logo. So if you're interested in talking about business things, then you can find out more there. Thank you.
Thank you, Jamison Dance. Thank you, thank you.